The final thing we are going to do with a speed time graph is convert it to a distance time graph. Now I am going to be honest with you and tell you that this is very, very, very unlikely to come up in an exam. But it is a fantastic way to test your understanding of speed time graphs and distance time graphs. Since it is so unlikely to come up, feel free to skip this and just focus on the basics of each type of graph. If you feel ready for the challenge, then stick with me. I'm going to go through this SciPad question with you. Once this video is done, SciPad has more ones you can practice with. Alright, so they've given us the speed time graph at the top here, and we're going to convert it to a distance time graph at the bottom. The first thing you need to do is calculate the distance travelled in each section. Remember, we do this by calculating the area under the graph. So we divide up the speed time graph into our triangles and rectangles. So for section A, we have a rectangle with a base of 5 and a height of 2. So in section A, they travelled 10 meters. Section B is a little bit trickier because we have that triangle and that rectangle. So we need to calculate both those areas. So for the triangle, remember we use half base times height. The base is 5. The height is, 8. Half times 5 times 8 is 20. And then we also calculate the area of that rectangle. So base times height, the base is 5, the height is 2, so 10 meters. We add those together to give us the total distance travelled in section B. So 20 plus 10 gives us 30 meters. Section C, we have a rectangle. So we use base times height. Our base is 5. Our height is 10. 5 times 10 gives us 50 meters. Then section D, we have another triangle. So we're going to do half times base times height. So half times 5 times 10 gives us 25 meters. And I'm just going to erase all that working out to make it a little bit neater and easier to see. Alright, so those were the distances travelled in each section individually. The other thing we need to know is the cumulative distance. So how far have they travelled up to that point? So at the end of section A, they've just travelled that 10 meters from section A. At the end of section B, they've travelled that first 10 meters and then an additional 30 meters. So we do the 10 plus 30 gives us 40 meters. At the end of section C, they've travelled that 40 meters from section A and B, and then they've travelled an additional 50 meters. So at the end of section C, they've travelled a total of 90 meters. And then at the end of section D, they've travelled another 25 meters. So in total, at the end of section D, they've travelled 115 meters. So we just add up until the end of each section. Okay, now we're going to start plotting those distances, those cumulative distances, on our distance time graph. So at the end of section A, or at the end of 5 seconds, they had travelled 10 metres, which is about there. At the end of section B, or after 10 seconds, they were at 40 metres from the start. At the end of section C, so at 15 seconds, they had reached 90 metres away from the start point. And then at the end of section D, so at 20 seconds, they were 115 metres away from the start point. So about there. So we just plot those distances against the times of each section. The final thing we need to do is join those lines up. And we can't just do a straight line because remember those different lines mean different things. So to do this, we need to look at our speed time graph. So in section A, there was a horizontal line. Now remember, those horizontal lines on a speed time graph means constant speed. How do we represent constant speed on a distance time graph? Hopefully you said with a straight line. So we're going to draw a straight line for section A. Then section B, on the speed time graph, we have an upward sloping line. Now remember, those upward sloping lines on a speed time graph means acceleration. So we need to show that on the distance time graph. And the way we show acceleration on a distance time graph is with a curved line. Don't like that. Which is a little bit hard to draw. Just do your best. Alright, section C, we have another horizontal line. So on a speed time graph, that means constant speed. So we need to show that on our distance time graph with a straight line. Straight enough. Then finally, section D, we have a downward sloping line on our speed time graph. So that shows deceleration. The way we can show deceleration on our distance time graph is a curved line flattening off. Alright, so we've produced our distance time graph here using a speed time graph. So remember, the steps to doing this is calculate the distance travelled, plot those distances against time, then join the lines together appropriately. So to do this, you need to know how to calculate distance from a speed time graph. You need to know how to plot points. You need to know what the lines on a speed time graph are, and you need to know what the lines on a distance time graph represent. So lots and lots and lots of skills involved with this. As I said, it is very unlikely to be assessed, but it is awesome practice. So I do recommend that you go into your SciPads and do the other questions for this. I think there's 2 more ones you can practice with. Alright, have fun and good luck.